Hello everyone, this is Mr. Ege and this is STEM design class, and we are focusing on the second video that the residential three-dimensional residential architectural building is we're going to be simply you're going to be adding two turrets on the left wing, and the left wing usually west side of the building. Okay, north wing is usually considered north, the upper side of the building. No, so two turrets, okay, will be balancing the entire architecture of the residence based on the two circles. Okay, so the first circle uh, is is the one with the radius of 0.75. Okay, inches. All right. This is a reduced scale, 144, 1 over 144 scale model, architectural model. And the first turret in the front that you are looking at it right now, it has a radius of 0.75 inches. Okay. That makes diameter of 1.5 inches. Okay. And basically, if you notice on the front side, the east wing is also 1.5 inches wide. Okay, the part of the building. The second turret on the left side, on the back side, okay, has the radius of 0. What is it? Let's zoom and take a look at it. 0.92. It's close to 1 inch. Okay, that means diameter of 2 inches approximately. Okay, and they are going to be positioned like overlapping with each other about say 50%. Okay, and then I just simply extruded both of them up. All right, the first turret reached to 2.6, 2.5, 2.6 inches high, and the last one on the back is even higher than that, and 3 inches. Okay, so today we're going to add two roofs on that, on both of them, and also I'm going to change the mode, the appearance mode, shade mode. I'm going to set say shade mode right now on, and there is a special version that enables you to see what's going on, realistic, or I have conceptual and realistic option right now. I don't have materials, so I'm going to be the conceptual option. Okay, all right. So the roof of the turrets, okay, is actually but a known geometry is called conic, and cone. It's a cone, and we're going to go to three-dimensional. We're going to workspace switching button at the lower right-hand corner and switch to 3D modeling menu. 3D modeling menu, it will enable you to access to the cone command. Before we do that, okay, you may want to move the UCS up to the center of one of the turrets. Okay, that will help definitely. So, and also make sure that your object synapse set to the center as well. So I'm going to check this out. Go into lower right hand corner, go to object synapse and select the center point. Okay, and then you type UCS, enter, and that computer enables you to pick the center point of the circle, click, and enter. Okay, so right now my UCS or icon, user coordinate system icon, is right now set right at the center of the first turret. Okay, and this is 0.7 radius, remember that, and the roof is going to be sticking out approximately normal circumstances 3 feet or 0.3 inches outside of the building exterior walls. So I'm going to go to the box on the lower left hand corner, okay, and I'm going to select the cone command. It's a conical roof, and the cone, okay, it says select the center point or the base point. That is 0, 0. I'm just typing 0, 0 because the center is right over here. Okay, and the second I'm going to pick up the end of the cone, and I don't need object snap for this, so I'm going to just select click on by hand, and that's totally wrong. I'll do this again one more time. Cone command, select 0, 0, enter. And the reason I need to turn off the object snap because I don't need the object snap at this point. And perhaps I don't need the dynamic input mode either. But I'm going to just simply type 1, okay, enter, and move my cursor up higher. All right. Again, 1.5 is good, so I'm typing 1.5, enter. Okay. So far so good. Cone looks good. And now I'm going to go look underneath, see if I can extrude the bottom part. Because anytime you have it's a roof, okay, roof has to have a trim extended right underneath the rafter. Okay? Every roof has to have a rafter, and every rafter has to have an extension covered with the trim. Okay, that's pretty much the rule of the game. Okay, so I'm going to use the not the extrude, but press pull. There's a press pull, the third icon from top left, and right underneath, the one next to this poly solid. You don't need this. Press pull. Move your cursor on the third icon from top left. Click on it, and select the eave underneath under the. Click on it, and bring it down a little bit. Again, 0.125 is good, and you can type 0.25 if you like to. Okay, and 0.125, enter. Good. Okay, so I think we're done. Escape. Okay, and Z enter for zoom, P enter for previous, Z enter for ZP, and that will give you a previous position. All right, and one roof is done. Yeah, you need another one. Okay, of course, save your work every time. Okay, you accomplish something. That's very important part of it. So what did we do? We created a user coordinate system on the top of the wall, the turret, and then we put it at the center. But we need the help of the object snap. Object snap, okay, we set the object snap to the center point of the circle, and also we turn on the object snap. Please remember that's very important. Turn on the object so that my cursor automatically, naturally, mathematically, accurately finds the center of the circle and picks your UCS. We want to move the UCS at the center. Why? Because we want to control 100% control over the dimensions. That's why. So again, any new command is UCS, enter. So now computer is asking you where to put the UCS. Move your cursor over the second turret in the back, towards the middle. When you see the mark, click on it and enter. Look if the XY plane is parallel to the top surface. Now it is ready, and it is. Right now, you can see this. Now it is ready for the creation of the conical roof. So command is cone, click. Okay, it's asking you center point of the cone, and you can 0, 0. That's your current. Okay, UCS. Turn off the object snap. Turn off the object snap, because otherwise it's going to mess up your system. This time, the dimension that I'm looking at here, 1.25. Okay, so 1.25. Oops, hold on a second. 1.25. This is your radius. 1.25. Enter. Now computer is asking you to select the top of the cone, and I'm going to select 1.5. Okay. Now, I think we have the two turrets are created. Okay, and the two turrets has now two roofs. Okay, but there's one more work to do, and union command so that we can join them all together. Union command will enable you to join everything together. Where do you find the union? You can type always union, but the menu, the solid model menu, has a union command. Okay, I go right under the visualize, under the E. No, There's a union command visualized under the solid union. Click on it. Okay? Select objects. I'm selecting all, A and L, enter. Ta-da! Good. How about the trim? Trim is very important part. We did the trim for the first part. We did not do the trim for the second. So we're gonna have to go and 12-inch trim, add the 12-inch trim. And for that, you need a press pull. Click on this. Go underneath the roof. Click under the surface of the trim. Okay. And this time, is what is it that we did use last time? 0.125. Is that what it was? Yes. So type 0.125. Enter. Okay. And save, of course. All right. Every time you accomplish anything, you just, okay. Save your work. And what is needed here? The most important thing right now is this is a solid model. It's full inside with the solid. We need to empty the inside. We need walls, exterior walls. And then later on, you can design the interior walls, but it has to be emptied. Everything is made from one single piece. Okay, right now it is full. So what is the command to get this done? To have an empty inside. We have the exterior walls. And exterior wall, what is the thickness of the exterior wall? Because you need to know ahead of time what the exterior wall, before you issue the command that will empty inside. Okay, there is a command, special command, and you cannot type. This is the only command you probably, or one of the few commands, you cannot type the name of it. It's a shell command. It creates a shell, like an egg shell. It creates a shell at any thickness you want, but it will ask you the thickness of the exterior wall. And what is the thickness of the exterior wall of a building of this magnitude? Well, it's about, say what? 6 inches to 12 inches. It changes, but 6 inches to 12 inches, it will work. Okay? So let's go with this. Where do you find the command here? Click, and there's a, right over here, move your cursor over from 1, 2, 3, 4, 5, 6, 7. Okay, the 7th icon from the top left, go down, click on the down arrow, and 1, 2, 3, count the 3 down, more, shell command. This is not ordinary shell command. You cannot type the name of the shell. So it's a solid edit shell. Click on it, okay? And now it says select the 3D solid. The entire building is the 3D solid. So I click the entire building and enter. Now it says, what's the shell distance? We said it's going to be 12 inches, right? You know what? Even if it creates it, I won't be able to see this. So I'm going to change the viewing mode. So shade mode, remember the shade mode we issued, and go back to wireframe. Why do we do this? Because I want to be able to see. Okay, I mean, it creates the exterior walls. Be able to see that exterior walls are created everywhere. Okay, all right. So again, shell command second time around. Click on the shell command. Click. It says select. Select the building, line, you can select the line. Enter, okay. And shell distance, 0.12, 0.12. Okay. Click on the shell, select the 3D solid model, enter, and 0.125 or 12. Okay. So if it doesn't work first time, try again or call me. Okay, we will work on this one together. Okay. And it did not work first time now, so we have to find out. And I'm going to just test it one more time. Solid edit, enter, and body, the shell, and 0.